Hello and welcome to Calculus Lesson 7. Today we're going to talk all about sinusoids and trig, and it should be a good time. So let's start with a discussion of the unit circle. So remember, the unit circle is a circle whose radius is 1. Unit 1, uni 1. It's a circle of radius 1. Anyways, anywhere along this circle, at a point, let's say you have a point x, y, the special thing about this is that since the radius is 1, your x-coordinate is simply cosine of the angle, and your y-coordinate is sine of the angle that this line makes with the positive x-axis. So that's pretty cool. So we like the unit circle. From there, we talk about graphs of sinusoids. So let's write out the general equation. We have y equals c, then it's plus or minus a sine or cosine of d theta minus phi. Okay, what do each of these stand for? C stands for the center line. So if I have a sinusoid here, the center line is the y-coordinate of that value. Then A stands for amplitude. That's the distance from the middle to the top. How do we choose which function it is? Well, actually it's all of them. So it could be positive sine, it could be negative sine, it could be positive cosine, negative cosine. And it just depends on what point you want to call the starting point. So if we call this point the starting point, we're going to use positive sine. If we call this point the starting point, we're going to use positive cosine. You can choose whatever one you want. I recommend that you choose the one that is closest to the y-axis. This is negative sine, and this is negative cosine, right? So that's going to dictate how you choose your function. That's this part. Finally, we have d, which is going to have to do with how quickly the sinusoid repeats. So what I'm going to do is I'm going to find 2 points where the sinusoid is in the same spot. And what I mean by that, like here and here, the sinusoid is in the same spot in the repetition, right? It's in the middle going up, here it's in the middle going up. And if I take this distance, this is called the period, or the time it takes to repeat, the period in which it repeats. We call the period this Greek letter called tau, and if I want to find d is simply 360 over tau, or if we're in radians, it would be 2 pi over tau. So that can be used. Whoa, went a little farther. No, I didn't. There we go. Sorry for the little, like, whoa. Finally, the phase shift is how far your function is shifted to the left or to the right. So depending on your choice of starting point, let's say we had a negative sine. If it was here, if the y-axis is here, that means it was shifted to the right, because it used to be there. It was shifted to the right this amount. That would be phi. Okay. This should be a review from pre-calculus, but I know it can be quite the challenge. So, we talked about period. The only other thing in this lesson, and a word of caution, if you're going to check your answers using your calculator, make sure you have it in radians. If you have it in degrees, oh dear, I have no eraser. If you have it in degrees, it's going to try and graph like 0 to 360 in this little spot. All you're going to see is a little line. So, have your calculator in radians if you are going to do that. All right, the last part is how we graph exponential functions. So an exponential function could look like this. Okay, the way we graph those is A, you could put it in your calculator, or B, and this is what I would really like, is for you to get a feel for what this function looks like. So you have an x value and a y value. X's are -1, 0, and 1. You're going to plug that in. So 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And that gives you 3 points. The only two ways an exponential ever looks is either like this or like this. It can be spread out, it can be steeper or shallower, but basically you have these two shapes. What I would encourage you is simply look at this number. If it's greater than 1, it's going up. So that would be y equals 2 to the x. And if it's less than 1, like if it's 1/2, it's going down. So if you were to graph 1/2 to the x, you would get that one. And that, my friends, is problem set 7.